Hello everyone, I am Dr. N.G. Praveena, working as Associate Professor in the Department of ECE at R.M.K College of Engineering and Technology. In this lecture, I am going to discuss about the types of the shift and rotate instruction that we use in 8086. So what are the topics I am going to cover here is the types of the shift and rotate instructions. So here I have listed out the types of the shift and rotate instruction: SHL, SAL, SHR, SAR, ROL, ROR, RCL, RCR. We'll discuss one by one in detail. The first instruction what we are going to discuss is about SAL, SHL. What is that SAL and SHL is meant for? The mnemonic is SAL, SHL. The meaning of it is shift arithmetic left, shift logical left. How the format has to be: SAL, SHL, D comma count. D is nothing but the destination register, whereas the count is nothing but the number of shift that we are going to apply for the data. Here the operation is performed in such a way that you are going to shift the content of the D register based upon the count value, and we are going to fill the vacated bits on the right side with zeros. When we execute this instruction, all the flags will be affected because sign flag, parity flag, carry flag, all the flags will be affected. Here it has been illustrated. I have a data, I have a register, here I have a carry flag. When I execute the instruction, right, the data will be shifted from right to left. Thereby the rightmost bit will be occupied with the zeros. Example: SAL CX comma 01, SAL AX comma CL. What does it mean, SAL CX comma 01? Here CX will have a data. How many times the shift has been taken here? 01. When you go for the second example, the content of the accumulator has been shifted based upon the content of your CL register. If I say CL is 1 or 5, based upon that the content of the AX register will be shifted. The next instruction what we are going to discuss is about SHR. The mnemonic is SHR, meaning is shift logical right. The format is SHR D comma count. D is nothing but the destination, whereas the count is nothing but the number of times you are going to shift the data to the right. Here the content of the destination register is shifted right, whereas the leftmost bits are filled with zeros. Here in this case all the flags will be affected while you execute this instruction. I have a register, it stores a data, I have a carry flag. When I move from left to right, can I understand? When I move the data from left to right, what happens here? The leftmost bits will be filled with zeros. Here I have an example: SHR CX comma 01. So 01 will be moved to the CX register. So what is the count of the shift I am going to do here? It's nothing but how many shift I am going to do here? One shift I am going to do here. SHR AX comma CL. So the content of AX register will be shifted, okay, based upon the CL, whereas CL count is 1. The next instruction what we are going to discuss is SAR. SAR is a mnemonic and the meaning of it is shift arithmetic right, and the format for this is SARD comma count. What we are going to do here? Here the destination register is shifted, shift arithmetic right. It is shifted right by the bit positions, okay, which is equal to the count. Thereby the leftmost bits are replaced with what? It's replaced with the original most significant bit. It is not filled with the zeros like your previous instruction SHR. Here the leftmost bits are filled with the MSB. Here in this case all the flags will be affected. Here I have shown the representation how the shifting has been done, including a carry flag. The example is same example here also we can take SAR CX comma 01, SAR AX comma CL. The next type of instruction what we are going to see is about the rotate instruction. First rotate instruction is nothing but ROL. Here rotate left. ROL D comma count is a format. When we execute this instruction, the operation which is going to be performed is we are going to rotate the destination register content equal to the count towards the left. While I shift the data towards the left, what happens, the rightmost bit will be moved to the leftmost bit. When you go with the shift instructions, here it will be filled with the zeros, but when you go for the right instruction, the rightmost bit will be moved to the leftmost bit. When we execute this instruction, all the flags will be affected. So I have shown here, when I execute this instruction, the data will be moved from right to left. So it will be moved. So when it moves, what happens here, the rightmost bit should be filled with 0 when it is a shift, but here is a rotate instruction, so the MSB will be copied once again to the LSB. Here the example is ROL CX comma 01, ROL BL comma CL. Here how many times the rotate has been performed here? It is one time. So we are moving 01 to the CX register. Then the next instruction is ROL BL comma CL. The content of the BL register has shifted once based upon the value of the count register. The next instruction what you are going to discuss is about ROR. ROR is nothing but rotate right. So the format of this instruction is ROR D comma count. Here we are going to rotate the destination register equal to the count value. When I rotate the destination data to the rightmost to the right, what happens here, the rightmost bit will be going to the leftmost bit position. Here also in this case, all the flags will be getting affected. The same example we can take here, ROR. Here the rotate, it is going to rotate the right, okay, based upon the count equal to the count. The next instruction is RCL. RCL is nothing but rotate left through carry. Here we are going to rotate the data including the carry flag register. So RCL D comma count. RCL D comma count, destination comma count. How this operation is going to be performed here? It is same as that of your rotate left, but here the carry is also attached with the destination, whereas in that case a carry will not be included here, but here the carry will be included for the rotation. While we execute, all flags will be affected. Example, RCL CX comma 01, RCL BL comma CL. You can take the same example. The next one is RCR. What is meant by RCR? Rotate right through carry. The format for this instruction is RCR D comma count. It is same as it of rotate right. Here we are going to take the carry for the rotation. In this case also, all the flags will be affected. When I move here, okay, from towards the right, what happens, the carry flag will be moved to the leftmost bit. Here the example what I have taken is RCR CX comma 01. Here the content of the register is going to be rotated once. So 01 is nothing but the count, the number of rotation is going to be performed on the register. RCR BL comma CL. So BL content has been rotated right based upon the CL content. Hope this video is helpful for you to understand the types of the shift and rotate instruction that we used in 8086. Thank you all.